I'm going to invite you to welcome our last speaker for this track today. His name is Christian. Welcome.
Thank you very much. Oh, thank you. Much too kind, much too kind. Do save the energy for the end. I hope the next 50 minutes will be very well worth your time, because I'm talking about a topic that's, I would say, interesting. It is very up to date. And there is quite some debate as well. So this should be both fun, interesting, valuable for your work, but still some food for thought and some discussion. I'm talking about the OWASP Top 10 today. So as most of you might know, the OWASP is the Open Web Application Security Project. It's a lot of volunteers that put together a lot of material about web application security, right? So a lot of checklists, documentation, events even, but the software, but the most well-known publication they do is their top 10 list, the list of the top 10 security risks for web applications. The list was released for the first time in 2003, then in 2004, 2007, 2010, 2013. So you get the pattern, right? So yes, there was something planned for 2016, but that didn't really work out. And then, you know, they changed leadership. They eventually issued a release candidate for the new list, then coined the OWASP Top 10 list 2017. And, well, here is what the release candidate looked like. Don't look at it for too long, because that's the release candidate. And when I saw this for the first time, I was kind of irritated by a few things. Look at number 7. Insufficient attack protection. Okay, so how do I prevent security issues? I don't make any security mistakes, so that's not really valuable, right? Insufficient protection. Well, also underprotected APIs. So English is not my native language, so I looked up in Webster's dictionary what is underprotected. I've never heard the word before. The word doesn't exist in the English language, right? So they just made it up. What he essentially meant is number 7 means make secure applications, and number 10 means make secure APIs. I do not get much value out of this. So, well, this was eventually scrapped, and actually 1 week ago, the 2017 list was actually released. So actually we are keeping our fingers crossed for the session, whether the list would actually come out on time. And well, depending on your definition of on time, the list was now released. And so what we are doing is we will have a look at the list for 2017, consisting, as the name suggests, of 10 items. I will cover those items, give you some, best practices. But I will also mention when I think that one item is not relevant for many of us, or if there is one item missing, because I do not completely agree with some of the items on that list. And of course, I'm also interested in your thoughts as well. But of course, that's all subjective. So if you think the list, as you will see, is perfect, then you will be very happy with that list. So this is the new list as of last week. Number 1, injection. Number 2, broken authentication. Number 3, sensitive data exposure. Number 4, XML External Entities. Number 5, broken access control. Number 6, security configuration. Number 7, cross-site scripting. Number 8, insecure deserialization. Number 9, using components with known vulnerabilities. And number 10 is insufficient logging and monitoring. All right? Now you've heard all of these 10 items, and for some items you may think, okay, yeah. And for some items you may think, what's that? And for some items you might think, that's rubbish. And with that in mind, we'll just discuss those 2 items. And I would like to start with item number 1, but before I do, let me just tell you how that list is assembled. So companies and other professionals that do a lot of audits, they try to crunch some numbers. So they submit data to the organization, essentially telling them, okay, this kind of risk, this kind of vulnerability has been found that often. And with all of that input, the OWASP top 10 team leadership tries to, find the priorities and make a list, find an order of all of these risks. So what is number 1 is the thing that appeared most often. And to my utter shock, an utter surprise since a decade. Number one is injection. And so people try to excuse this a little bit and say, yeah, you know, Christian, injection, there's so many things in injection. There's SQL injection, there's LDAP injection, XPath injection, even regex injection is possible. Actually, I kind of invented this, but I've never seen this in the wild, so let's just strip this out. But of course, if people talk about injection in the context of the OWASP top 10 list, 99.9%, they talk about SQL injection, which irritates me a lot. Because not only is SQL injection as old as SQL, it's also a problem that has been solved. I mean, it depends a little bit on the technology you're using, right? So if you're using, let's say, Java or .NET, which are at least in web development number 2 and number 3, then chances are that you are using a kind of object relational mapper. Hibernate, NHibernate, or entity framework. And if you're using PHP, there are also many options for R mappers. Now, the problem with SQL is an architecture problem, because in SQL is basically a string containing commands and data. And if the user supplies this data, if it's formed the correct way, then this data can be turned into commands. And that's SQL injection, in short. But if you have an OR mapper, then you don't have this mix-up anymore because you just have an API. So that problem is solved. Even if you don't have an OR mapper, you can use parameterized queries, for instance. Every technology is using that. Every template is using that. Every other framework tries to build their own wrapper around that so that you have no chance to actually write SQL statements and to get SQL injection. This sometimes goes wrong. You may have heard the news a couple of weeks ago. A vulnerability in WordPress was found. And that vulnerability essentially was a bug in their custom prepared statements mechanism. A very similar thing happened to Drupal, I think 2 years back. Well, it's not always a good idea to reinvent the wheel, but still. I mean, it is really, really hard to get SQL injection. Now, why is this number one? Because of legacy applications. Right? So if you have legacy applications, chances are, okay, you audit them because they are so old, you kind of have a hunch that there's something wrong there. And then you find SQL injection, and therefore it's still the number one security risk. And that both shocks and depresses me. This should not happen to anyone in this room, right? I've made many security mistakes and continue to make security mistakes, I'm very well aware. But SQL injection, no chance. And I hope you see that the same way as I do. Number 2 is a bit more generic. It's called broken authentication. Well, the problem is HTTP is, as the protocol specification says in the second sentence, a stateless protocol. What does stateless protocol mean? Stateless protocol means doesn't remember anything. There is no state. So in order to remember something in a web application, we have to resort to, say, sessions. And that's a hack, right? And so there are various attacks against the session hijacking, but this requires an additional vulnerability. Session hijacking, which most web frameworks nowadays don't allow any longer. So why is this number 2? Well, also legacy applications plus high-profile incidents. So according to the OWASP definition, unencrypted passwords also kind of belong to broken authentication. And there have been many incidents in the past, and you've certainly read about many of them. And one thing I always like to point out is the Adobe hack. So Adobe kind of lost a lot of user data, but at least they encrypted their passwords, so it's not really a case for broken authentication. However, there were 2 issues with that. One issue was the way they encrypted the passwords. If 2 people have the same password, the data stored in the database would be the same, right? So identical password, identical encrypted value in the database, which is a bad thing. I mean, you shouldn't actually encrypt passwords. You just create a hash with a salt and store these 2 values. That was one thing. And the other thing was they wanted to implement something like, well, remember your password, you know, these security questions, your mother's maiden name or something that you can easily find out using social engineering. But they had a better idea. They were using something that also some operating systems used to do, password reminder. So you don't have to answer a question, you get a password, you write your own reminder that hopefully reminds you what your password is. And those passwords, those password reminders, they were stored in clear text. Now think of this. So a lot of people, they do have the same password, which we know because the encrypted data is the same. So we can kind of, bring them in order. And well, the top password usually is whatever, 1, 2, 3, 4, 5, 6 or something. But even better, of all of those hundreds of people that have the same password, we also have 100 password reminders, which makes it easy. It's like a crossword puzzle, if there was a crossword puzzle. Turns out there is a crossword puzzle, so someone actually turned this into a crossword puzzle. So actually we can, if you want to try this out, how about the one down here? So this says, so here are the password hints. I hope you can see this also from last row. So this is Adobe, Adobe X2, Adobe 2, Adobe twice. I have a hunch what that password is, right? So how about we try Adobe. So what's next? Maybe this one here, 10 across. Let me in, knock knock, open sesame. I think you have an idea what that password could be, right? But the worst thing about this is, if you look at the password hints, the third one, usual, right? So what would really fit, of course, is let me in. Yeah, it's the usual password. So people are reusing this, and if you crack this one, you could also crack other sites. The person that is part of the Adobe database is registered at, right? And that is the problem, right? I mean, the actual problem here was that, in that case, Adobe, lost the user data. I think it was done using SQL injection, but I don't even know for sure. But the problem with that was that now all of these passwords, the passwords themselves couldn't be decrypted, but they could be deduced from the password hints, right? So things can go terribly wrong, and I think this was a pretty enlightening example, I hope. Number 3 is sensitive data exposure. But sensitive data exposure is something that has been solved. You just have to do it. Use encryption, especially use encryption for your web application using HTTPS, exclusively HTTPS. I mean, just a while ago, people said, no, we don't use HTTPS because it's so slow, and the performance is going down for a web application, and an SSL certificate is so expensive. But these are just bad excuses. These are really, really bad excuses. Look at the conference we're here at, right? So at this conference, we all are in the same Wi-Fi network, or at least most of us are. And Wi-Fi basically works, and I simplify things here a bit, is that everyone who is connected to the Wi-Fi gets all of the data, and the driver or piece of software responsible for the Wi-Fi on our machines just picks out the data meant for us. So what do we do? Or what does an attacker do? Uses a special driver that also gets the other information and, for instance, logs it. So if you, let's say, read email and you don't encrypt your connection to the email server, other people can read your emails too, right? And same things are, of course, true for web applications. So please, please, please use HTTPS. Use HTTPS throughout. If possible at all, don't even allow HTTP. There is one thing that I find is pretty interesting, can be very valuable here. It's something called HTTPStrict transport security. That's a relatively new standard supported by all modern browsers. And what HSTS or HTTPStrict transport security does is that the web server sends an HTTP header to the client, strict transport security, instructing the browser that from now on, for a certain amount of time, you provide that in the header, all requests to that server must be using HTTPS or for WebSockets WSS. So no more HTTP. That's pretty amazing. And even better, modern browsers, they come with a list of websites where the strict transport security is automatically enabled. Try this out. Go to, let's say, Chrome, and then go to Google and just look at the network tab of the Google developer tools, and you will see that the browser doesn't even try to access Google via HTTP. It starts with HTTPS. And the good thing is, your website can also be part of the list. So there's a mechanism where you can just submit your website. Your website has to be configured in a specific way, has to send out a specific header. But if that all works, then in a subsequent browser update, your website will be part of that thing. So it can be a small site, a private site, a commercial site, a big site. Doesn't really matter. And many websites already take part in this. So yes, number 3, valid point, and something that can be solved rather easily. I do have a big problem with the next point, point number 4. And the thing is, it's a bit technology dependent. So very quick, please, show of hands. So who is doing, let's say, Java development for the web? Okay, quite a bit. Who's doing .NET development for the web? Okay, and who's doing PHP development for the web? Let's just take the big 3. Okay, so it's about a third each, give or take. Now, the thing is, the next item, I have a specific code sample in PHP, which I'm about to show you, but the idea is, it's called XML External Entities. In XML, you can have entities, right? And you can reference external URLs in those entities. And this attack, XML External Entities, works in the following fashion. So you have an application, and that application is processing XML. I mean, I have processed a lot of XML in my life, but in the last few years, I mean, no XML for me, right? So maybe JSON or something else. And the idea here is that if you have a parser that automatically resolves those entities, you might be able to craft an attack. I put the link here on the slide, so you can have a look at that one later, which does a very nice explanation where one of these vulnerabilities was exploited. However, all technologies kind of disable this external entity resolution feature, so you have to manually enable it. So it's a weird thing, I really have to say. Now, just that you can get an idea. So what I was doing here, I was using a PHP here because it's easier to demonstrate this. And that's actually code I took from the PHP documentation. What this basically does is it's opening an XML file, and then it's kind of parsing it, and then I output the XML file. And the idea is this attack only works if the attacker manages to provide an XML file. So not only are we parsing XML, but we are parsing XML that comes from a malicious user. So a lot of things have to align for this attack to work. So this is how the XML might look like, right? So I have this XML file here, and I have an external entity referencing the conference website. And we won't be able to see that 100%, but if we just go to the page I just put here. Well, you see here in the top where my mouse pointer is. So yes, indeed, the DevTernity website is loaded. The way I'm outputting it, you don't see everything. I mean, you see the icon down there. But basically now I have loaded the XML, but thanks to my configuration, I'm now actually loading the website referenced. I mean, that's pretty interesting, if you ask me. But number 4, really? I mean, when you came here for this talk, right, and you were interested in web application security and thought about all of the things I would mention, would you think that this is number 4? Aren't there a few things you have in your mind that I haven't mentioned yet? So I'm not sure about the number 4 thing. I really am not. Supposedly, especially in finance transactions, there is a lot of XML being parsed. But still, I mean, as usual, your mileage may vary, but I do not agree with the number 4 here. Right. All right, number 5 is pretty interesting. Well, actually, it's not pretty interesting, but it's pretty positive if you have had a look at the 2013, so the previous OWASP top 10, because there were 2 items, insecure direct object references and missing function level access control. Which kind of meant the same thing, but yeah, they wanted to put 2 items on that list. That didn't make any sense. Access control is key nowadays. So a lot of applications are using, if it's not a single page application especially, they are using like an MVC approach. And what they are also using is the get post redirect pattern, right? So you get HTTP get a form where you can type in some things, then you post it back to the server is storing the data and then redirecting you to the overview page. And how often have I seen that the get page, the page that is retrieved using HTTP get, is protected, right? So the application checks whether the user is allowed to see this, but post isn't. Because sometimes developers think, well, you know, if the attacker doesn't see the form, why should the attacker actually post data back to the server? Well, there are good reasons why attackers are still be able to do that. So whatever you do, whenever you have something that only certain people, certain roles are able to see, are able to do, always check access control to data and to functions. I did an audit earlier this week, and so one company, they were creating PDF reports. So it was an insurance company. But what they did is they put the reports in a directory where you could directly access it via HTTP. And they said, well, you know, it's impossible to find out the file names, right? Because the file name contains the timestamp. Well, go figure, right? So I just try out a few timestamps, like 1 million requests per half an hour, something like that. And so they finally believed me and they fixed this, right? So this is number 5, and this still happens a lot. Sometimes it's easy to spot, sometimes it's harder to spot. But even if there is a hypothetical chance that an attacker finds such a vulnerability, it needs to be fixed. And well, my experience is that when there is a vulnerability, the chance that an attacker finds it is always 100%. All right, so number 5 is still, let's say, is still fine. Before I go to number 6, sorry, I always forgot something. One thing I need to mention, because I think it's pretty interesting, is something called CORS. Now, more often than not, when we have, let's say, a single page application, right? We have a lot of things going on the client, and then we do API calls to the server. But those API endpoints on the server, they have another origin. So origin is the term used in JavaScript, and we'll have a look at that in a bit. But basically, origin means, well, the server where the API is located at, right? So the application is maybe at domain.com and the API is at api.domain.com. This is not possible because of a security restriction in JavaScript, right? So the browser prevents us from doing that call, more or less, unless the server greenlights the browser. And that's called CORS, cross-origin resource sharing. The server then sends a specific HTTP header, access control, allow origin. Yes, I know, very long word. And that kind of whitelists the caller. But the problem here is some people are lazy. And so they just say, you know, I never know, I have a test server and a dev server and another server. I just do access control, allow origin, star, right? I allow everything and everyone. And indeed, then the application works beautifully no matter on which web server you deploy your application. But what also works beautifully is several kinds of attacks where attackers then abuse the user's browser in order to call that, right? So if you use cross-origin resource sharing and if you have an API, chances are you do be as restrictive as possible who to allow to call the API. Right. All right, but that was number 5, and I would like to end this point with a very great tweet I found. So you may have heard, or you certainly heard, that the character limit for tweets was increased to 280 bytes, right? So for some people this is amazing because they can tweet twice as much rubbish as they already did before. But there was one thing, there was a group of people that had this feature earlier than others, right? This guy did not. And it's a long tweet, but if you read it, what he's basically saying is that this Twitter actually increased the character limit to 280 for everyone. However, they checked for the 140 character limit in the client application, so in the app and in the browser. So if you kind of, jiggled a little bit with the F12 tools in your browser, you could also send 280 character tweets before you were actually greenlit to do that. Right? And this shows that even the big companies sometimes make this mistake. And of course, that's number 5, broken access control. So Twitter thought, well, if the text field for my tweets is limited at 140 characters, how is it possible that someone is sending more than 140 characters? Well, of course there are ways, because in the end, it's just an HTTP request, right? So it happens to the best of them. And this was actually, as you see from the date, pretty recent. All right. What's also relevant here and a bit related is this this ticket on GitHub, which was opened in 1001 years. So actually, this was, I think, 3 years ago. So now the ticket would say it is opened in 998 years. I find the concept of time travel pretty interesting and intriguing, yet I just do not believe that this gentleman managed to do this. What happened here? Well, they were using a framework, I won't name which one, but maybe you have a hunch, and that framework was implementing the active record pattern. So what basically happening is this. On the server, they have a model, right? So the model for such a ticket is maybe property of title, property of description, and a property of creation date. And when creating a new ticket, you have 2 text fields, one for the title, one for the description, and then an HTTP post request is sent with title equals I'm Bender from future and description equals etc., right? Now the problem is, what happens if this HTTP post request also contains creation date equals 1st of December 3018? Well, since there's magic going on the server which transforms the string data from an HTTP post request into a model in the programming language of choice, and creation date was also a property of that model, that property could be set by just adding data to the HTTP request. And therefore, you could open a ticket in the future. And all of the technologies that allow this kind of, some call it model binding on the server, are hypothetically vulnerable to that. Because they just accept any data and then, stuff it in the instance of the class that's created. So what can you do here? And I mean, all technologies have solved this, but you have to manually do this. Either you have a whitelist. So in your code, you just say, this is a set of properties. These properties are bound to the data from the HTTP request. The other ones are not. Or you do a blacklist. You can bind anything. I just don't care. But don't bind, say, creation date, right? And so these are all variations of item number 5 on that list. And well, I've also found this pretty interesting. All right, number 6, security misconfiguration. I'm a developer. So if something goes wrong, whose fault is it? No, not my fault. No. I'm flawless. Well, I'm not, but I claim to do. I always say it's the admin's fault, and this works quite a lot. But of course, it's a coward thing to do, and it's just plain wrong, right? And the problem is, I mean, if you look at the schedule of the conference here, right, there's so much which kind of belongs to DevOps. So everyone is kind of an administrator now. In some shops or companies, there's a specific team that kind of configures the server. In other shops, every team has to take care of that themselves. But there are several aspects. You can harden your server, you can harden the operating system, but you can also harden the technology you're using. So definitely do that. What's also relevant is that if you have error messages are great for developers because you get lots of information and stack traces. But the problem is you're the only person that should actually see this piece of information. So don't send out detailed error messages. One pattern we have been using quite a bit in the past was that if there is a kind of exception on the server, what we do is we log that exception in a database and create an ID for the database entry, let's say a GUID. And in the error message we are sending back to the client, to the web application, we just send the GUID and a boilerplate error message, like something went wrong. But if someone is really that keen on, finding out why this error appeared, they can send us the GUID, and then someone can look up at the GUID, okay, what kind of error actually was that? So the user doesn't see any valuable data, but the developer can. Right? So this, I think, is pretty nice. There's also something which belongs to the topic of security misconfiguration. Modern browsers, they have support for several security headers. So these are HTTP headers that add extra layers of security. One pretty interesting or pretty useful site is securityheaders.io. And what you do here is they are sending a request to your website and then finding out, how secure is the website. Now, this looks like, really bad and red, but take all of this with a grain of sand, because, it really depends on what happens on the website. So DevTernity.com, the website I just called, that's the start site of the conference with no data, because it just says, okay, this is the conference that's running now, and this is the conference that's running next year where you can already get tickets, right? I do not see that much potential for security issues on that site, so this is not bad at all, okay? But still, it might be valuable, and I'm showing you this for a specific reason. Eventually, you maybe want to get your web application audited. And there are good auditors and there are bad auditors. But even the bad auditors, they can run such a tool and then just say, look at this, there is red, I don't know what it means, but there must be a security vulnerability because that site says we have an F, okay? So consider adding those security headers just to satisfy the auditor, okay? All right, so we have 6 out of 10. Isn't there anything you're missing? Any, typical attack you have heard of a lot? Oh, there is one. Crosssite scripting. Yeah, crosssite scripting was in the top 3 since 2003. This is the first time it fell out of the top 3. That's weird, because I see crosssite scripting almost every day. Well, the problem here is that frameworks and technologies try to get much better at adding crosssite scripting protection, right? If you have, let's say, a templating engine, most templating engines, templating engines work usually the following way. So you have an HTML snippet, and then somewhere in the HTML snippet you output something. And a typical crosssite scripting attack goes like this. An attacker sends you, let's say, JavaScript, and somewhere in the application you output this JavaScript, thus crosssite scripting. But many templating engines, they now escape data automatically. So if an attacker tries to send JavaScript, the JavaScript is escaped and the threat is mitigated. So that's maybe why crosssite scripting fell down that list. But still, let me spend a few minutes on crosssite scripting, because I still think it's not only very relevant, it's also very dangerous. So when people are demonstrating crosssite scripting, and I'm no exception here, what they usually do is something like, script alert 1, right? And then you get a modal JavaScript pop-up, and then the guy demonstrating says, see, super dangerous. But all you see is a JavaScript pop-up, which doesn't hurt, right? Well, it's a bit worse than that, actually. There are several types of crosssite scripting. Type 1 and type 2, I think, are pretty well known. One is persistent, so user sends JavaScript to the server stores it and then serves it every user. And type 2, reflective crosssite scripting, means JavaScript is, for instance, part of the URL, and then when you load that URL, JavaScript code is output, and bam. There's a third one, and the third one is something people usually haven't taken into account, but for single-page applications, this happens quite a bit. You have JavaScript in the URL. The JavaScript code in the application is taking out the data from the URL and then including it in the page's output. And so it's getting more and more dangerous. And the problem is this. So imagine you have a website, right? And on this website, you have inline JavaScript code. That's the first orange box. Then you have an external JavaScript file on your own server. And then you load JavaScript from somewhere else. I took good old trusted jQuery here as an example. But it could be, Angular. It could be anything. Right, and the security principle of JavaScript is the so-called same origin policy, which looks at the protocol, the domain, and the port of something, and the combination of this is the origin. And the same origin policy says, essentially, that JavaScript only has access to stuff, which could be a DOM, elements on the page, etc., that has the same origin. Now, I don't like the term origin. Why don't I like the term origin? Because it's misleading, if you ask me. Why is it misleading? Because what's the origin of the inline JavaScript block? Yeah, it's example.com, port 80, right? What's the origin of script.js? Yeah, of course, that's example.com. But what's the origin of the jQuery library? And the answer is, the origin, as in same origin policy, is example.com. Why? Because the origin of JavaScript code is always the origin of the HTML page loading or including that JavaScript code. Otherwise, jQuery wouldn't be able to manipulate the DOM on that page, right? Because same origin policy. So I don't like the term origin, because the file resides here on code.jquery.com. That kind of sounds like origin, so I hate the term. So I always say security context. JavaScript code always runs in the security context of the HTML page loading the JavaScript, which means, and that brings us finally to cross-site scripting, if some attacker manages to inject JavaScript code in our page, the JavaScript code has the same privileges as our own code. And that's what makes cross-site scripting so pretty dangerous, right? That's why we need to fight it. And I mean, in theory, it's simple. Just escape output. Angle brackets, double quotes, single quotes, ampersand. And if you're in the JavaScript context, also escape backslash and a few other characters. But still, it doesn't seem to work. There's cross-site scripting all over the place. So years ago, all browsers, except for Firefox, have started adding a cross-site scripting filter in their browser. So they have a heuristic in a browser that tries to find out whether a cross-site scripting attack takes place, and if so, they block it. They try to be super careful here, no false positives, so only if the browser is absolutely sure that it's cross-site scripting, it does block it. Actually invented, or the inventor of this protection is, and it's a surprise, I think, to everyone in the room who works with web browsers, the best browser ever seen the light of day, Internet Explorer 8. Now you're laughing, I hate Internet Explorer 8, but a lot of security features were added in Internet Explorer 8, and all the other browsers actually adapted it, right? So this browser was, from a security point of view, back then, a good browser. Anyway, so there is this protection in place, but still it doesn't protect from anything. Yet, I am convinced, and I mean, I do security since 16 years now, and I have been convinced for at least 15 out of these 16 years. But this year I'm so convinced that I say next year it's gonna happen. So if you see me at next year's DevTernity, please come see me and ask me if I'm still convinced. But no, I'm really convinced now. Cross-site scripting will die. And why will cross-site scripting die? Because of something called content security policy. Content security policy is a W3C standard, which works like this. We have an application, and the server sends an HTTP header to the client, instructing the browser where to load any content from, where to execute any content. So it can instruct the browser, only load images from these servers, only load JavaScript code from those servers, only load style sheets from that server, and only load web forms from that server. Very fine-grained control. Of course, the JavaScript aspect here is the most interesting one, right? So we can restrict where to load and execute JavaScript from. And there is an additional feature. If you're using content security policy with JavaScript, then inline code is deactivated. That's interesting. So I use a content security policy. I can say only load JavaScript code from, say, my own server, and don't execute inline JavaScript code. How would a cross-site scripting attack now take place? If the attacker manages to inject script alert 1, that's inline code, won't be executed. If an attacker injects script src equals attacker.com/badscript.js, wouldn't be executed because attacker.com is not whitelisted. The only way in that scenario where a cross-site scripting attack would work was if an attacker manages to upload a JavaScript file to our server and then injects scripts src equals evilfile.js. But if an attacker manages to upload JavaScript files to our server, then cross-site scripting is the least of our problems, right? So in that case, it doesn't really make things any worse because they are horrific anyway. All right, so that's why cross-site scripting is maybe a bit further down the list, but it's still one of the most relevant problems in my opinion. But with content security policy, I'm very optimistic that eventually the problem will go away. All right, number 8, insecure deserialization. And I have to use a PHP example here because especially in PHP, this sometimes can be used pretty effectively. The idea is this. We have to serialize data when we, let's say, use strings. A typical example would be API calls where we provide some JSON or any kind of serialized information. And then the technology is deserializing that. And deserialization means input is a string which could have been manipulated by the user, and then on the server, this string is converted into an object of the language or technology of our choice. Is that bad? Well, sometimes it is, sometimes it is not. The problem is that, for instance, PHP, and that's why PHP is a good example here, and there are a few PHP developers here in the room. PHP has a couple of so-called magic methods in a class. The idea is if a class has a magic method, let's say __ wake up, and that method is implemented. Whenever an instance of that class is deserialized, so turned back into an object of that class, that code here is run. So you might eventually trigger some code, and therefore a catastrophe is near. Actually, it was a very nice exploit against the deserialization mechanisms of various web platforms, I think 1.5 years ago at a big security conference. And they found a couple of issues, but those issues were fixed, right? So also, is this number 8, is this more important than, let's say, cross-site request forgery, which didn't even make it in the list because it's on number, I think, 12 or 13. I am not too sure. Follow rule number 1, validate all input. And I think then even this hypothetical problem is more or less easy to mitigate. Number 9 is something that sounds obvious. Using components with known vulnerabilities. Does that happen? Does that really happen? Well, I have a pretty nice example here. It's a local example. So I come from Germany, and we have several, let's say, train providers. But there's a market leader, the former state train provider, and they have the displays at the stations they run, right, which show you, okay, this train is departing at that time at that track. And here is an actual picture from, I think, a year ago at one of many train stations, and I think all of the train stations in the whole country looked exactly like this. And you may have kind of recognized this Windows application here on top. Yeah, exactly. That's this. We encrypted your system. Please send us a few bitcoins, and then we might eventually decrypt your system, which we won't do. Back then, Bitcoin was cheap, right? So I hope the attackers, if they got the money, that they didn't spend it all. But wait, it's for Bitcoin conversion. Yeah. Of course, that's very embarrassing. In the web context, the problem is maybe not as grave, but still, when you use libraries, when you use frameworks, when you use a specific stack, it's your obligation to define and execute a process that periodically checks whether there are updates, whether there are security critical updates, and then do install them. And I mean, I sometimes, miss the days, back in the days, right? So the older people in the room maybe can remember those days where you didn't have a stack. You just had a technology, the one that existed, and you were using that technology. And you wrote all your code on your own. You were reinventing the wheel every second day because you only had to patch one thing, the technology you were using. But nowadays, I mean, create a new Angular app, right? You have 180 megabytes on your hard drive for Hello World, with a lot of packages, depending on lots of packages. And then you somehow have to keep them updated, but also have to be sure that an update doesn't break backwards compatibility, right? It's trickier these days, but even more important it is to have a process for that and actually watch out for security critical updates, right? And yeah, it's, I mean, I'm happy that we now have the possibility and we have so much great open source software. But on the other hand, it's just more things to take care of, right? All right, and finally, number 10. Number 10 is insufficient logging and monitoring. And a lot of people tell me, yeah, we are logging. And then I ask them, okay, who's checking your logs? When do you check your logs? And then they say, well, I mean, we are logging, right? Isn't that good enough? It's like when people tell me, yeah, I have a backup. It's awesome to have a backup. And I hope everyone in the room has a lot of backups. But have you tried a restore? A backup is only working if the restore is working, right? And it's the same with monitoring and logging. So not only do log, but look at the logs. So this is the OWASP top 10. And yeah, it's, I mean, it's I think still a relevant list, but there's some things which I don't understand. XXE on number 4 is a bit irritating. Cross-site scripting so far behind towards the end of the list is a bit irritating, but what's more irritating is what's missing in that list. And there are several things that might be missing. The most obvious thing that's missing is cross-site request forgery. So cross-site request forgery, according to the number crunching of OWASP, is now number, I think, 12 or 13, therefore not part of the top 10 list. But I see cross-site request forgery so often. And of course, cross-site request forgery is a solved problem, right? So you just make sure that you have one-time tokens, or at least tokens that the attacker cannot guess, and you send those tokens along with your HTTP request, but still, that's a thing you need to do. You usually don't get this out of the box. And therefore, when I'm doing audits, I see cross-site request forgeries a lot, so maybe I just do the wrong types of audits, but still, I think this is a very relevant attack. And what's also, let's say, a related attack, but I understand that that's not, let's say, enough for its own entry on the OWASP top 10 list, is clickjacking. So let's have a look. So I have here a page, right? It has a button here, do not do this, because if I click on that button, something really bad happens, right? Shall I click? Oh yeah, what the heck. And it says here, no party tonight. Well, you may have heard there will be some organizational changes today. Please do come to the closing keynote, because there the new plan will be unveiled. So the thing is, I do not want to click on that button, right? So this button could be something like, okay, I order something, or I delete something from our system. So a click that changes something. Okay. Now on an entirely different server, I have here a simple link. That link goes to google.com. And there's nothing fishy on that page here. Well, let's say there's something fishy with that page, but there's no JavaScript on that page, okay? Is that good enough? And the problem is when I click here, then suddenly it says no party tonight, which is maybe not what we wanted. So what happens? Well, if we look at the code, let me change the code on a little bit. So this is how the page really looks like. So the page with the button is here in an iframe, but I used CSS to make that iframe invisible. So I set the opacity technically. And when I wanted to click on that link, I was actually clicking on exactly that button, right? And I mean, that's probably the most dangerous of all attacks, because you know the user just wanted to click on something, but clicked on a button they didn't want to click on, and that's super dangerous. And I mean, this is the amateur demo version of that attack. There's a professional version looks like this. The iframe moves where the mouse pointer is moving, right? So wherever I'm clicking, I'm always clicking on that button without even seeing it. Horrible. What do you do? Well, actually it's pretty easy. We must prevent that our page, and our page would be the one with the button, right? That's the page we control. That page must not be loaded in an iframe. So if you've done web development in the 1990s, I mean, if you remember the 1990s, you haven't lived the 1990s, but if you happen to do, and happen some JavaScript that does frame busting, you could do that. Or you could use more modern techniques. X-frame options, HTTP header does exactly what we want. It just prevents pages from being framed. And that's just one HTTP header to send, but that's another thing that makes every auditor happy, and that prevents this really, really dangerous attack. Still, it's not part of the list. And so in closing, I would say that, yes, the list is still relevant, especially if you're new to web application security. I don't find the list is balanced enough. I don't agree with some of the items on the list and the order in which these items became part of that list. But it's an open source project, so instead of complaining here, I should and I do try to contribute and also provide feedback. The next list is then due in 2020, so I'm really curious to find out how the list will look like back then in the future. And as I always say when I talk about security, better be paranoid than offline, right? So any security mechanism you're doing is making your web application better. And with that, I thank you for attending DevTernity and hope you have a great time tonight and maybe tomorrow if you're still there. And enjoy Riga, and thank you very much. Thank you.
All right, we still do have time for one or two questions, if there are any. Yeah, I don't see a question on the slide. There is only one comment, though, that says that _blank is an underestimated security vulnerability, according to a website that is here in the comment.
That's correct. How much time do we have left? Like 30 seconds? We have 30 seconds left.
Well, it's fine to answer this, and that would be it.
Yeah. Okay, I have time. Just stay here. The doors are locked. Okay, because it's a very good comment, so I'd like to actually go to that. So, typical page, right? And the page has an external link. And remember the page 1. So I click on that page, and another page opens in a new tab, okay? What do you do then? You close the tab. What will happen if I close the tab? We get the old tab, right? The old page. So what are you expecting to read? Page 1, right? I close the tab, and now it says bogus page 1. Why? Because the new page I just opened can redirect the previous page. So Instagram was hit by that a couple of months ago. Also not part of the top 10 list, but I think it's a very, very creative new attack and shows that even basic HTML can turn into a security issue. If you want any more information on that or any on the other topics, feel free to reach out, tweet me or send me an email. And yeah, now with that, doors are unlocked. Now you're ready to go. Thank you.
Okay.